my intention today is to go through normalization. First, tell you what the normalization is, why we do normalization, what are the benefits of normalization, and then show you the rules of normalization. So far you've learned that given a scenario, a problem, a specification, you can identify entities, attributes, set primary keys, find the relationship, set the foreign keys. Of course, you still have got a couple of more weeks, till week 7, another 3 weeks to master this, your skills and do your assignment. So my role is here for the next couple of weeks to make your life easier and facilitate your learning so that you can solve the problem with the assignment fairly easily and understand what's happening. What we talked about so far in the database design was, given a scenario, given a problem specifications, like you've seen in the last 2 weeks in the tutorial, you will read the scenario, try to understand what's required, find all the data items that is required for that organization from which the problem is generated or the scenario is generated, find the entities, attributes, primary key, foreign keys, etc. Of course, when you look around in your class, in your tutorial, you could have several designs for the same database. And some of these designs are a little bit better than the other. Well, how would you know where your database design or your design for the database of the given scenario is a good design or not? So normalization is a technique that's used to check, to go through your solution and see that the identified entities, attributes, etc. follow certain rules, which are the rules of good design. So normalization aims to provide you with a set of rules that you can apply to your solution to improve your solution if there are some problem with your solution. Okay? So the definition in the book says normalization is a set of techniques for producing a set of suitable entities that supports the requirements of an organization. So there we'll be doing under normalization, there's not only 1 or 2 or 3rd normal form, and each normal form represents a set of rules. So you could go normal forms, 4th normal form, 5th normal form. So normalizations starts from 1st normal form, 2nd normal form, 3rd normal form, 4th normal form, 5th normal form, etc. As you go beyond the 3rd normal form, sometimes a too optimized design is not a great design. So if you can apply up to 3rd normal form rules of normalization to your design, that should be sufficient for a very good design of your database. Okay? Although the book may say there are other steps that you can take, but I think by 3rd normal form you have got fairly good design. So when we say what is a good design, what is a suitable set of entities or relations, are those that have got the minimum number of attributes. That doesn't mean that you have to have reduced number of attributes. That means only store those attributes that's required. Okay? And I'm telling you, always store as much as you can, as much as you think is required, and depending on the problem. So don't just say, I want to have a very good design, therefore I'm not going to store all the attributes. So when we say minimum, it's the minimum number of attributes that can represent everything you want, that can give all the information that your organization needs. And then finding the attributes, yes?
So does that mean like store date rather than day, month, year?
No, not necessarily. The question is this, does it mean to store date instead of day, month, year? No, it doesn't mean. And actually, I think I should remove this from my lecture notes because I'll confuse you. What it means when we say with the minimum is that we don't have really the applications in the storage of the attributes. So if you're storing, for example, the name and address of the customer in the table customer, then if you're referring to the customer somewhere in another entity, for example, you have got a payment, customer makes a payment. Let's say you've got two entities. One is customer with the customer number, name, and address. The second one is the payment, which is the payment number, customer number, date of payment, amount of payment. So instead of in the payment putting the name and the address of the customer, just by putting the customer number, you're doing the reference to the table customer. And then from the customer number, you can find the name of the customer, the address of the customer. Does this make sense? That's what we're saying. So you don't need to store the name and address of the customer in the table customer and then in the table payment. That's what we're saying. Don't think you say, if you have got an entity with the 3 attributes, it's better than an entity with 5 attributes. It doesn't mean that. So when I say minimum here, and what your book says, the minimum number that will satisfy all your needs of your organization. In a sense, in really what we're talking about, not duplicating attributes in multiple entities. No duplications of attributes unless it is necessary, and in some cases it could be. In very rare cases, the correct relationships between the entities, that's what we are talking about. So we are talking about choosing the right entities, choosing all the entities, choosing all the required attributes, setting the proper primary keys, setting the proper foreign keys. That's what we're talking about in normalization. So the whole idea of normalization is provide you with a set of rules that you can apply to your solution and check your solution to see that you have got all the entities, you have got no redundancy, no duplications of attributes that are not necessary to be duplicated. You have got the relationships properly set. Okay? So the whole idea is to reduce redundancy and duplications and setting it and basically fixing the relationships and if there is any ambiguity in relationships, etc. So what are the benefits of having a good design for your database? Having a good design for your database make the usage, once the database is designed based on your good design, it's easy to handle, it provides all the data we need, it's easy to manipulate the data, right? So you will see when you go from design into implementations in your assignment 2 where you design given a scenario, you design the database and then you build the actual database and you access the data, manipulate the data, you will see that if your design has got some deficiencies, then your database is not as useful as it should be. So for example, if you forgot to store some attributes, you forgot to set the relationships properly, you chose the wrong primary keys, etc., you'll see then it's very difficult to use this database. Right? So the whole idea here with normalization is we provide you with a set of rules to check your design, improve your design, get rid of problems or errors in your design if possible. You know, sometimes the designs are logical, so you haven't chosen an entity. So if you haven't chosen an entity, you didn't pick it up from the scenario, normalization is not going to help you. Normalization, given a design, will try to optimize it, try to make it more efficient. And the whole idea of having a good design and efficient design without redundancies is, and having all the relationship is that once your design is converted into an actual database, it's easy to handle, it's easy to use the database, and it provides you with all the information, all the data that you need for your organization. So far, you should have no ambiguity. You should not be scared. I know that when you read this chapter, it's not easy. It's actually badly written. It's one of the bad chapters, badly written chapters in your textbook. I think most of the chapters are good, but this one is a bit confusing. And that's my role here, to just get the confusion out. And I ask you to pay attention for the next 20, 30 minutes so you don't have to suffer when you read the book and it doesn't make sense. So what we're saying here is this. Have a look here. The whole idea is that that's what you've been doing so far. So you interview your users, you check the organization, you observe, you write the requirements for developing a database. So far, what is happening in this subject, the requirement, the specification is provided to you, so as a tutorial question, as your assignment. In reality, in most cases, you have to look at the organizations, how they handle data, where they store the data, do they use, for example, forms to fill in the data, how do they keep the records on a piece of paper, in a file, etc. And then from that, you write the requirements for developing a database. So users are very involved because you talk to them and say how they handle data, how they store data, where the data comes from, how do they collect the data. So for your case, so far has been, you start from the second stage here. The requirements is given to you. And then from the requirements, and requirements is coming from the user interviews, from checking, observing the processes that's happening in an organization, looking at the forms that they generate, looking at the reports that they generate, etc., and then make the specification. Once you've got the specification, like your assignment and specifications, hopefully you have got minimum number of ambiguities or minimum ambiguities in your specifications. You go and you design. Okay? With your design, what you did was you read the specifications and then identified entities and the attributes of those entities, and then you set the primary keys, and then you find the relationship and you set the foreign keys. That's what you did. Next thing you did, you drew an ER diagram, which was a diagram that shows the entities and the relationships between entities according to your solution. All right, here what we're talking about is this. You can do two things. You can have a top-down approach or a bottom-up approach into checking your design. So you've done the entities attributes, you set the primary keys, you set the foreign keys, you draw the ER diagram. You're in this stage now. You've got a solution, you want to check it. So you apply normalization techniques that we will talk about. So you can apply the normalization techniques to your document that contains the entities, attributes, primary key, foreign keys, or you can apply it to your ER diagram, or both, one at a time. So that's what we're saying here. This diagram that you see comes straight away from your book is telling you that the normalization techniques can be applied to your ER diagram or to your document that contains the entities and attributes.